What can happen when you combine high-performance computing and advanced internet research? You'll find out next. Welcome to SC21 TV. I'm your host, Charla Bokikio. SC21 TV will be live throughout the conference this week with in-depth interviews with industry leaders and influencers. I'm here with Joe Mambretti, the director of the International Center for Advanced Internet Research, I-CAIR, at Northwestern University. Welcome, Joe.
Pleased to be here. Thank you for the invitation.
Yeah, happy to have you here. So give us a brief description of I-CAIR, first of all.
Okay.
And also the Starlight International National Communications Exchange Facility.
I'd be happy to do so.
Please.
So for the first, the International Center for Advanced Internet Research is a research entity within Northwestern University. Our research focuses on basically large-scale transport. For people in networking, it's actually layer 1, layer 2 networking. The name is a bit of a misnomer because internet is mainly layer 3. So we're optical and layer 2. But our focus is not just large-scale transport, but more specifically, large-scale transport for data-intensive sciences, which is why we're here, science communities. We support many large-scale sciences, high-energy physics, astrophysics, radio telescopes, computational biology, bioinformatics, genomics, computational chemistry, etc.
Right.
So a wide variety of sciences. We also do something else as part of our mission. We design, implement, and operate test beds for network and, to some degree, computer research. And at any given time, we're supporting about 20 major test beds to promote new concepts and bring them into operations. The third thing we do is actual production services. We run a 7-statewide regional network for data-intensive science. We also run a facility that you mentioned in Chicago called the Starlight International National Communication Exchange Facility, which started out as the world's first facility for interlinking international research education networks, and now is a sophisticated exchange for over 100 private networks, including all the major international R&D networks, all the federal agency networks, statewide networks, local networks, multiple test beds. We have over 100 gigabit per second connections.
Wow.
And we're using that facility for supporting experiments and demonstrations at this conference.
Excellent. A lot of good work. So what are some of the initiatives that you're interested in communicating here at SC21?
Well, our main thrust, as I said, is supporting next-generation networking services for data-intensive science. Science is now moved to having another pillar beyond, theory and experiment, which is modeling, simulation, using increasingly large amounts of data. So, unlike general internet, which is aggregation of millions of flows, people doing consumer things or enterprise things, many science communities need extremely large data flows end to end, and that's not generally available. And we promote and develop with our international national partners capabilities for doing those services for the big scale sciences. And we like to showcase them as we are doing here.
Excellent. So given the current projects that you're working on, what are you looking forward to in 2022 and beyond that? Where's the future?
I would say more of the same except bigger and better, faster. So one way people look at this is by scale of capacity. For example, we work with the SciNet WAN group, Wide Area Networking Group, to provision a specialized network for the conference. This year, that would be 6 100 gigabit links coming from California, 2 400 gigabit waves from McLean, Virginia. So that's 800 gigabit. And then from the Starlight facility to the show floor, 1.2 terabits. And we're using those to support a wide range of different demonstrations. AI for advanced science networking, software-defined networking, software-defined exchanges, and much more.
Excellent. So anything else on the global social media that our global social media viewers should know about you and the organizations that you lead? Maybe the lay person. What would you like to tell them about the work that you're doing? Someone that's not in supercomputing.
I think the message for the wider audience is that data-intensive science has always driven innovations in advanced networking. Most people don't know where the internet came from. It came from a National Science Foundation project to interconnect supercomputers. The web browser was invented at CERN, a particle physics lab in Switzerland. The more common mosaic that later became a phenomenon was done at the National Center for Supercomputing Applications. So this community actually sees the future years in advance of the more common consumers. So what they should do is use this telescope into the future to view what the future will look like, because they can see it here now.
I love that. That's incredible. Very well put. We were talking about AI creating Shakespeare earlier. I think that's such an interesting concept.
That's Vince Cerf's speech,
right.
keynote here.
Absolutely. So just on a side note and something completely personal, what is a fun fact about you? Something that would surprise most people listening?
I probably have no fun facts.
Oh, come on. A childhood dream or a pet, something personal.
Well,
a special skill that you have outside of supercomputing?
I think a special skill is I've always had a great curiosity about science, and that's what brought me into this field. Is I was at the University of Chicago working with something that didn't even have the label computational science, but it was Fortran for physics, and I worked with them and became very intrigued with the whole world. I've been doing it ever since.
Excellent. So, were you one of those kids that were doing science experiments in the kitchen?
I was not, but I was tinkering with things. So I was more on the mechanical side, take it apart, see how it works.
Perfect. Excellent.
Like doing that.
Well, anything that we missed? Anything else you'd like to share?
Well, you mentioned the future and what's coming, and I mentioned the capacity part. The other side of that coin is the programmability. So a big important thrust of a lot of what we're doing is software-defined networking or programmable networking. And it's very exciting because it's bringing networking to a new level. Excellent.
Well, great. Thanks for chatting with me, Joe.
Thank you.
Appreciate it. So we stay tuned for the latest in supercomputing from SC21 TV. Make sure to like us on Facebook and subscribe to our YouTube channel for more SC21 throughout the week. And be sure to make plans to join us next year. I'm Charla Bokikio.